In a two-stroke petrol engine, lubrication occurs by mixing oil with the petrol, so oil passages are not needed. And if, like many two-strokes, air cooling is used instead of liquid cooling, there's no need for coolant passages in the cylinder head. Another difference between four-stroke and two-stroke petrol engines is how they deliver air-fuel mixture to the cylinder. In a two-stroke petrol engine, separate passages called ports let air-fuel mixture into the crankcase and cylinder and exhaust gases out. They're covered and uncovered by the piston as it moves up and down the cylinder. In the four-stroke petrol engine, the inlet and exhaust ports are opened and closed by valves. These valves need a system to control how they work. The valve is held in place by a valve guide with a spring on its stem. A rocker arm is attached to a stationary shaft that allows the arm to pivot. The rocker arm compresses and releases the valve spring so that the valve opens and closes. Let's run the cycle again. The piston moves up the cylinder. The top of the piston covers the exhaust port, the bottom uncovers the inlet port. Air-fuel mixture enters and circulates in the sealed crankcase below the piston. The piston rises and compresses the mixture above it. A spark plug ignites it and it burns. Pressure from the expanding gases pushes the piston down in a power stroke. The top of the piston uncovers the exhaust port and lets exhaust gases escape. The bottom of the piston covers the inlet port and forces air-fuel mixture up into the now open transfer port. The piston reaches bottom dead centre and the crankshaft forces it back up to repeat the process. Notice which events occur above the piston. Compression of the air-fuel mixture into the combustion chamber, combustion for the power stroke, and scavenging of the exhaust gases. Notice the events that occur below the piston. Intake into the crankcase, pre-compression of the air-fuel mixture in the crankcase, and the transfer of mixture from the crankcase through the transfer port and into the combustion chamber.
A two-stroke, or two-cycle, engine is a type of internal combustion engine which completes a power cycle in only one crankshaft revolution and with two strokes, or up and down movements, of the piston in comparison to a four-stroke engine, which uses four strokes. There are usually three ports, an inlet port, exhaust port, and a transfer port. The transfer port connects the lower chamber beneath the piston to the upper chamber above the piston. The first stroke of the two-stroke petrol engine begins with the piston about halfway down the cylinder heading toward the top of the cylinder, going upwards. Because the piston is halfway down the cylinder, all of the ports are covered. Because of the upwards motion of the piston, the bottom chamber below the piston falls below atmospheric pressure. As the piston moves closer to the top of the cylinder, it uncovers the inlet port, which then, because of the pressure in the lower chamber, sucks air and fuel into the lower chamber. The second stroke of the two-stroke engine is carrying on from the first stroke, which sucked the air into the lower chamber. The piston has nearly reached the top of the cylinder. Just before it does, the mixture of air and fuel in the upper chamber above the piston is ignited. The high pressure of the burnt gases forces the piston down. On the way down the cylinder, the piston recovers the inlet port, stopping any fuel/air from being sucked into the lower chamber. As the piston moves downwards, the mixture of air and fuel in the lower chamber is being compressed. When the piston gets to be DC, bottom dead center, the exhaust port is fully uncovered, which releases the burnt fuel in the upper chamber, and also draws fuel and air from the lower chamber through the transfer port into the upper chamber, ready for the next stroke. The first stroke of the two-stroke petrol engine begins with the piston about halfway down the cylinder heading toward the top of the cylinder, going upwards. Because the piston is halfway down the cylinder, all of the ports are covered. Because of the upwards
Now we're going to spend just a few minutes to review some fundamentals of the most basic technologies employed in outboards today, two-stroke and four-stroke design. Even though they have their distinct differences, they each offer specific benefits for customers. With the knowledge of the key components of two-stroke and four-stroke technology, you'll be able to better apply an understanding of the innovations that Yamaha has introduced over the years in refining these power systems. Yamaha two-stroke and four-stroke outboards use the same basic principles of any internal combustion engine. Compress atomized fuel within an enclosed cylindrical space, ignite it, and the expanding gas releases a significant amount of energy. Repeat these controlled explosions thousands of times a minute, using the created energy to drive a series of pistons and transform that energy into rotation and torque through a crankshaft. That is the baseline operation of the internal combustion engine. Well, today there are two popular mechanical designs to make that power, two-stroke and four-stroke engines. Both use a variant of an intake, compression, combustion, and exhaust operation cycle. Let's take a look at how they make their power. We'll start with the two-stroke. Now, the term two-stroke means one firing cycle or combustion process is performed for every two strokes, one up, one down, of the piston, or one 360-degree revolution of the crankshaft. Here's what that looks like. In a two-stroke engine, the fuel intake process is called scavenging. As the piston moves downward, the intake or transfer port opens. The air-fuel mixture that's been pressurized in the crankcase passes into the cylinder in exchange with the burned gas to be exhausted from the last combustion. On the compression stroke, the piston moves upward. The scavenging or intake port and exhaust port closes, and the air-fuel mixture is compressed inside the cylinder. As this happens, the crankcase develops negative pressure, a vacuum, that pulls open one-way reed valves to draw in new air-fuel to enter the crankcase to be pressurized and get ready for the next firing cycle. Just before the